Question: a spaceship is traveling with a velocity of 0.7 c away from a space station. The spaceship ejects a probe with a velocity of 0.59 c opposite to its own velocity. A person in the space station would see the probe moving at a speed x into c. What is the where the value of x is dash? So in the question, they have given a spaceship moving away from a space station with a velocity v1 is equal to zero point 0.7 c, and they have said the spaceship ejects a probe in the opposite direction with the velocity v2 is equal to minus 0.59 c. The minus denotes it is moving in the opposite direction to the movement of the spaceship. And they have said a person in a space station is viewing this motion of the probe, and he sees its velocity as x into c. They have asked us to find what is this value of x. We know that the value v is equal to v1 plus v2 divided by 1 plus v1 v2 divided by c square. v1 and v2 values are known. Substituting it, we will be getting the velocity of the probe as 0.187 c. Now in the question they have already given velocity is equal to x into c. By comparing it, we can find x value as 0.187. Question: in the context of small oscillations, which one of the following does not apply to the normal coordinates? Option A: each normal coordinates has an eigen frequency associated with it. Option B: the normal coordinates are orthogonal to one another. Option C: the normal coordinates are all independent. Option D: the potential energy of the system is a sum of squares of normal coordinates with a constant coefficient. In this question, we have to find which among the four option is incorrect in case of normal coordinates. Now you take the option A. Each normal coordinates has a eigen frequency associated with it. This option is correct. Each normal coordinate is associated with the only one frequency of vibration. So option A is correct. Now take option C. Option C says the normal coordinates are all independent. Yes, it is also correct. Now option D. If we take the normal coordinates as x1 and x2, the potential energy can be expressed as the sum of the squares of normal coordinates with some constant coefficient. So option D is also correct. The only incorrect option is option B. So answer is option B. An interstellar object has speed v at the point of its shortest distance r from a star of much larger mass m. Given v square is equal to 2gm divided by r, the trajectory of the path is circle or elliptical or parabola or hyperbola. So in this question, they have said that an interstellar object is at a distance of r from a star. Okay, it's moving with the velocity of v square is equal to 2gm divided by r, and they have asked us to find what is the trajectory of the object. Kepler's first law helps us to find what is the trajectory of the object by finding the magnitude of the eccentricity E. So the eccentricity E is given by root of 1 plus 2 E j square divided by m k square, where E is the total energy, j is the angular momentum, m is the reduced mass, and k is the constant. So this table tells you what is the nature of the object based upon the value of E. So when E value is greater than 0, eccentricity is greater than 1, and under that case the nature of the orbit is hyperbola. And when E value is equal to 0, so energy value is equal to 0, the eccentricity value is 1, and it is parabola, the path is. When E value is energy is less than 0 and E is also less than 0, that is eccentricity, and the path is elliptical. When E value is equal to minus of m k square divided by 2j square, that eccentricity value will be 0. Under that case, it is going in a circular path. So in this case, we have to find what is the value of E and substitute it here and see what is the value of eccentricity. So based upon the energy value, the eccentricity value is getting changed. So we have to find the total energy of the object, that is interstellar object. That is kinetic energy plus the potential energy. As the body is moving with the velocity v, the kinetic energy will be half mv square, and potential energy is minus g small m capital M divided by r. In the question already they have given v square is equal to 2gm divided by r. Now substitute the value here, and we will be getting at g small m capital M divided by r minus g small m capital M divided by r. This says that the total energy of the object is 0. Now we have to find what is the value of eccentricity. So when energy value is equal to 0, the eccentricity value is 1. So under that case, the object is moving in a parabola path. So answer is option C. Question: if H is the Hamiltonian for a free particle with mass m, the commutator x, x, h is. Option A, h cross square divided by m. Option B, minus h cross square divided by m. Option C, minus h cross square divided by 2m. Option D, minus h cross square divided by 2m. So in the question they have asked us to find what is the value of this commutator, and they have given h is a Hamiltonian of the free particle of mass m. So first we will write the given commutator x, h. We need to know what is the value of h. In the question they have already given h is a Hamiltonian of a free particle. So for a free particle the Hamiltonian h is given by p square divided by 2m. Substitute the value here, and here 1 divided by 2m is a constant term, so it can be taken outside. So we will be taking the 1 by 2m outside, and remaining we will be getting commutator of x comma p square. We know a general formula. The commutator of x comma p of x power n is equal to n into I h cross into p of x power n minus 1. By using this formula we can simplify this. So here the n value is equal to 2. So by applying this formula we get 2i h cross p power 2 minus 1, and here 2i h cross is a constant that can be taken outside, so we will be getting x comma p. Now by applying the same formula and simplifying it we will be getting I h cross. So by simplifying this we will be getting minus h cross square divided by m. So the answer for the given commutator is minus h cross square divided by m. Answer is option B. Question: for the transformation q is equal to root of 2q e power minus 1 plus 2 alpha cos p, p is equal to root of 2q e power minus alpha minus 1 sin p, where alpha is a constant. To be canonical, the value of alpha is dash. So in the question they have asked us to find what is the value of alpha so that q and p are canonical. We have studied that to form a canonical transformation, the Poisson bracket of q comma p is equal to 1. That is dou q by dou q, dou p by dou p minus dou q by dou p by dou q is equal to 1. First we have to find what is the value of these four partial derivatives. So first we will take q and find dou q by dou q, then dou p by dou p, and then we take p and find that dou p by dou p and dou q by dou p by dou q. Now after finding this we will find what is the value of this particular partial derivative, multiplying this one, that is dou q by dou q and dou p by dou p, that is this one. We will be getting e power minus 2 plus alpha cos square p. Now we will find what is the value of this partial derivative multiplying these two, that is dou q by dou p and dou p by dou q, that is minus e power minus 2 plus alpha sin square p. Now we have to subtract this term and this term and equate it to 1. So we will be getting e power minus 2 plus alpha cos square p plus e power minus 2 plus alpha sin square p. We can take these two terms as a common term and we will be getting sin square p plus cos square p, that is equal to 1. So simply we will be getting e power alpha minus 2 is equal to 1. So 1 is nothing but e power 0. So by equating the powers we can get alpha value is equal to 2. Question: a uniform circular disk of mass m and radius r is rotating with angular speed omega about an axis passing through its center and making an angle theta 30 degree with the axis of the disk. If the kinetic energy of the disk is alpha m omega square r square, the value of alpha is. In the question, they have given a kinetic energy of a circular disk that is rotating at an angle theta is equal to 30 degree, and they have asked us to find what is the value of alpha of the kinetic energy. So we know that the kinetic energy of a rotating disk is equal to half into j dot omega. So j dot omega is nothing but j omega cos theta. In the question, they have given the value of theta as 30 degree and j is equal to I omega. So we will be getting half I omega square cos theta. Now we have to find what is the moment of inertia of this circular disk. Moment of inertia of the circular disk is equal to half m r square. But now we have to substitute the value of I in the kinetic energy part. So T is equal to half into half m r square omega square cos 30 degree. Cos 30 degree value is root 3 by 2. So we will be getting the kinetic energy of the circular disk is root 3 divided by 8 m r square omega square. In the question, they have already given the kinetic energy of the circular disk is alpha m r square omega square. By equating these two, we will be getting alpha value is equal to root 3 divided by 8.
In the description box, you can find solution for GATE Physics 2020 and 2019 question papers. Please share and subscribe the channel. If you have any queries, write in the comment section.